Now we are discussing about the carrier concentration of p-type semiconductor. This carrier concentration of p-type semiconductor and density of holes in valency band. The p-type semiconductor is having majority carriers or holes in valency band. The p-type semiconductor is having majority carriers of or holes in valency band. So this p-type semiconductor, how it forms means we can see here in the picture. Pure semiconductor fourth group elements. It is a pure semiconductor means intrinsic semiconductor. This is intrinsic semiconductor is going to be fourth group elements. So the fourth group elements are called pure semiconductor elements or pure semiconductor material. If you add plus doping, plus means doping, if you add it, impure elements like third group elements, which is having only 3 electrons, outermost orbit, it is having 4 electrons. So this 4 electron fourth group element, this 3 electron third group element, if you mix it, automatically p-type semiconductor will form. So due to adding of third group elements, due to adding of pure and impure elements, due to adding of impure elements third group elements, which is having 3 electrons, in energy in the band diagram, here acceptor energy level is going to form. This acceptor energy level is formed due to this third group elements mixing with fourth group elements. This third group element mixing with the fourth group element, this third group elements are giving, this other group element is giving this acceptor energy level. And in this entire p-type material we are having conduction band, valency band, intrinsic energy level, acceptor energy level, Fermi energy level, valency band. So like this, conduction band, intrinsic energy level, acceptor energy level, Fermi energy level, valency band. This acceptor energy level is coming due to what? Due to third group elements, which is added to fourth group element. Now to calculate carrier concentration of p-type semiconductor or density of holes in valency band, we have to take number of acceptor atoms per unit volume is equals to Na e power of minus of Ea minus Ef by kBt. So the number of acceptor atoms per unit volume is given as Na e power of minus of Ea minus Ef by kBt. This equation number I am taking it as a 1. Now we know the density of holes in valency band or number of holes per unit volume in valency band is written as 2 into 2 pi mp star kBt by h square whole power 3 by 2 e power of Ef minus Ev by kBt, equation number 2. So if you observe, the number of holes per unit volume is written as means in energy diagram, when temperature is somewhat increased, the valency band electrons are going to shift from valency band to acceptor energy level. By small raising of temperature, the electrons are going to shift from valency band to acceptor energy level. That is why here hole is formed, here electrons are present, here holes are present in valency band. In acceptor energy level, electrons are present. So the number of holes per unit volume, the number of holes per unit volume in valency band is written as 2 into 2 pi mp star kBt by h square whole power 3 by 2 e power of minus of Ef minus Ev by kBt. Here sometimes you can write Kb is equal to K also, no problem. Next what we are doing is number of acceptor atoms per unit volume is equals to, we are writing number of holes per unit volume in a valency band. This equation and this equation we are making equal. So density of acceptor atoms in density of holes, density of acceptor atoms per unit volume and density of holes are equal. So Ne into e power of minus Ea minus Ef by kBt is equals to, I am writing 2 into 2 pi mp star kBt by h square whole power 3 by 2 e power of minus of Ef minus Ev by kBt. Just already we have this number of atoms per unit volume, acceptor atoms per unit volume, and is equals to what we are writing, number of holes in valency band per unit volume in a valency band. So that is how much, 2 into 2 pi mp star kBt by h square whole power 3 by 2 e power of minus Ef minus Ev by kBt. So both we are doing and simplifying it like this. What we are doing is, this e power of minus Ef minus Ev by kBt is taken into this side. E power of minus Ef minus Ev by kBt is taken as a denominator of e power minus of Ea minus Ef by kBt. To that one, this one as a denominator. So you can see here, e power of Ea minus Ef by kBt here it is there, divided by this value we are doing. Cross multiplication I am doing. So this Na value is sending this side. That is why this value already I have written the same value as this 2 into 2 pi mp star kBt by h square whole power 3 by 2 as it is I have written. This Ea I am sending to this side, so it becomes like this. So cross multiplication, this is coming this side and this is coming this side, then it becomes like this. Now what we are doing is reciprocal of above equation we are doing. Reciprocal or inverse of above equation means this value I am writing down, down value I am writing top, and the down value I am writing numerical value I am writing in denominator value I am writing numerator value I am writing in denominator. So exchange of values, numerator, denominator, numerator. So this value we got here in denominator by doing this. This denominator value we are writing above. So this is called inverse of the equation. The same thing right hand side also. Na is top and 2 into 2 pi mp star kBt by h square whole power 3 by 2 is taken in the denominator. So rest, this is called inverse of above equation or reciprocal of above equation. So what we are doing is here e power of Ef minus Ev by kBt as it is have written Ef minus this minus Ef plus Ev minus Ef plus Ev by kBt. You can see carefully this minus is sent to inside, minus Ea minus into minus plus Ef by kBt, that we have written here, don't get confused. And here also we send like this, minus into Ef minus Ef minus into plus minus into minus plus, that is plus Ev, that is written here, minus into Ea minus into minus plus Ef by kBt is written here e power. Now in this case minus Ef minus into Ef minus into minus plus Ev by kBt is written here, and as it is 2 into 2 pi mp star kBt by h square already we got, that is there here written, this value is sent here. Now we are doing reciprocal of equation we are doing. So reciprocal of equation, if you do it, you can get the answer. So in in the above two equations, if you see carefully about two equations, reciprocal about you are doing this e power of Ea minus Ef by kBt, we are writing as a denominator, and e power of minus Ef minus Ev by kBt is writing as a numerator. This is called reciprocal. Next, Na is writing in numerator. 2 into 2 pi mp star is kBt by h square whole power 3 by 2 written as a denominator. Now further simplification, what we are doing is this one. We got the same values, this value right now. From here to here, what we are doing is, it is also having kBt, it is also having kBt. If you bring it as a numerator, it becomes plus, it becomes minus. So first we will write e power of Ef minus Ev by kBt, e power of minus Ef minus Ef minus Ev minus Ev. Here if it goes up, what happens? It becomes plus Ea, it becomes plus EAC. If it goes up, what happens? Minus Ef minus Ef. It is having kBt, it is having kBt, that's why we are writing 1 kBt is equals to Na as it is, and 2 into 2 pi mp star kBt by h square whole power 3 by 2 as it is we have done. So left side no change, only right side we have done from these two steps. Now we are taking e power of minus 2Ef means minus Ef and minus Ef. So minus Ef and minus Ef and minus Ef is equal to minus 2Ef, Ev as it is, Ea as it is. So same equation, but we have done minus Ef and minus Ef, it does a minus 2Ef in the above equation. Remaining plus Ev plus Ea, same as it is done. kBt also, kBt as it is done. So the same equation, what you have done from here to here, the same equation is present. So right side no change, as it is we are dumping from here, means Na 2 into 2 pi mp star kBt by h square whole power 3 by 2. What is there? Here we are done. So here we can get, so the same values in left side values are not getting changed, as we are writing left side same value we are dumped here, the same value we are dumped here. So that's all. Only right side simplification we have done. Now we are writing here minus 2Ef by kBt Ev plus Ev plus Ea by kBt. We are writing how, means like this. The previous equation was, our previous equation was like this. This is our previous equation. E power of, by taking logarithm both sides, means here we are taking logarithm, here we are taking log. For the whole term I am taking logarithm like this. Both sides I am taking logarithm. When I take this logarithm both sides, what happen? We have a formula log e power x is equal to x. The same way log e power x is this one, total value is x. That is why it is going to become as a x only. X like this. That is why we are writing here minus 2Ef by kBt plus Ev plus Ea by kBt, as it is we are getting. This is called just like x. So this equation and this equation, if you compare, log e power x is equal to x. This is x. So that's this x value we are writing by doing small simplification. So that is what? Minus 2Ef by kBt plus Ev plus Ea by kBt plus Ev plus Ea by kBt as is equals to So this equals to we have written here. And the previous value is what you have done previous value. NA as it is NA by 2 into 2 pi me star kbt by h square whole power 3 by 2 last equation. So 2 into 2 pi mp star kbt by h kbt by h square whole power 3 by 2. So this is what we got in last equation. This equation after taking logarithm, this total equation is going to become like this. So actually we have to show you like this due to page convenience. I am unable to tell you this one. So once again I am explaining this. Carefully listen to me. Log e power x is equal to x. Last equation. So log e power x is equal to x. But in the previous case we got, here we got, for this one I am taking logarithm. This equation is there. This equation is there. For this equation I am taking log both sides. I am taking log both sides. This equation is equal to 2 EF minus EV by minus 2 EF EV plus EA by KBT. The same equation you can take NA by 2 into 2 pi MP star KBT by h square whole power 3 by 2. The same equation we have taken. Both sides we have taken what? Logarithm is equal to both sides we have taken logarithm. Then according to the formula of log e power x is equal to x. Log e power x is equal to log e power x is equal to x. So log e power x, that is going to become x only. So that we can see here x. Log e power x is equal to x. This is x. So that the same x we are getting here. This x. This is x now. That x we are getting here. So that is why x value is how much? Minus 2 EF by KBT. Minus 2 EF by KBT. Plus EV plus EA by KBT. So that's why same value. So log value as it is we have taken here. But what is that? Log NA 2 into 2 pi MP star KBT by h square whole power 3 by 2 here also whole power 3 by 2. So equation we got like this. EF by K minus 2 EF by KBT EV plus EA by KBT is equal to log of NA by 2 into 2 pi MP star KBT by h square whole power 3 by 2. Got it. Now what you are doing is this EV plus EA KBT is sending that side. This value send that side. Minus 2 EF by KBT send that side is equal to right side. This log of NA by 2 pi MP star KBT by h square whole power 3 by 2 send this side. Then becomes minus log. It becomes plus. So if you send that side, I am writing first that value. If you go that side, this entire value, if it is going that side, right side of equal to, then it becomes plus. So 2 EF by KBT. So next, EV plus EVA by KBT is as it is equal to this side only. This we are sending that side now. Then what happens? Minus log, it becomes minus log. NA by 2 into 2 pi MP star KBT by h square whole power 3 by 2. So same value. If it this entire value is moving that side. This entire value is moving that side. This entire value is moving that side. This entire value is moving this side. Then we are getting this equation. This equation we are getting. Now from this equation, what we are doing is 2 EF by KBT EV plus E is equal to EV plus EA by KBT minus log of NA by 2 into 2 pi MP star KBT by h square whole power 3 by 2 is that. in this case. So this 2 by kBT we sending this side, cross multiplication I am doing. So this kBT I have written here by this 2 I have written here for the first term, as it is I have written here, minus I have written. After minus, this we are sending that side now. So kBT, again kBT by 2 we have written log of NA I have written 2 into 2 pi MP star kBT by h square, 2 pi MP star kBT by h square whole power 3 by 2 whole power 3 by 2 written. Now next final equation, if you go, if you go for final equation, this kBT gets cancelled. So what happens? EV plus EA by 2, EV plus EA by 2, EF as it is. This kBT gets cancelled. EV plus EA by 2, EV plus EA by 2 minus kBT by 2, kB2 by 2 log of NA 2 pi MP star kBT by h square whole power 3 by 2, 2 pi MP star kBT by h square whole power 3 by 2 as this. So this is called position of Fermi energy level. Position of Fermi energy level. According to temperature. Now case 1 we are taking. Case 1. If you take case 1, T is equal to 0 Kelvin. If you take this T is equal to 0, if you write in this equation, this entire term is going to become 0. This entire term is going to become 0. Then what happens? EF is equal to this, EF is equals to EV plus EA by 2 as it is, minus 1 by 2 into KB into 0 into log of this T place we are getting by 0, log of NA by 2 into 2 pi MP star kBT by h square whole power 3 by 2. T is equal to 0. So 0 into something 0, 0 into something 0. So finally EF is equals to EV plus EA by 2 minus 0. So finally we can write EF is equals to EV plus EA by 2. This is the final equation for case 1 when T is equal to 0 we are getting. Now we are writing now case 2. Case 2 is as it is. Case 2. In the case 2 we are writing the same value as it is. Case 2 is written as same as this. T is equal to T Kelvin. Then what happens? EF is equal to EV plus EA by 2 minus 1 by 2 kBT log of NA by 2 into 2 pi MP star kBT by h square whole power 3 by 2. This is the value. This is when case T is equal to T Kelvin. This is called Fermi energy level position. Now from this equation we can say that the energy level, Fermi energy level position moves up. Valency band, conduction band. So it is acceptor energy level A. This Fermi energy level EF. This EF will move like this and will go to nearby EF value. EF. So it is sliding from here to here according to this equation. According to this equation, when temperature T is equal to T Kelvin, when temperature T is equal to T Kelvin, this Fermi energy level moves to up. Means above Fermi, above acceptor energy level, this Fermi energy level is going to move up when temperature T is equal to T Kelvin. But now in this case 1, Fermi energy level will be like this. Conduction band CB, valency band VB, and this EA Fermi energy level is this one. Yep. So EA plus EV by 2, EA plus EV by 2, EA EV. This is exactly between these two the Fermi energy level exists. Density of holes in valency band of p-type semiconductor. Now the density of holes in valency band in p-type semiconductor. The density of holes we have to calculate. For the purpose I am taking the p-type Fermi energy level position. Just we have calculated EF is equal to EV plus EA by 2. Just we have calculated this value. Minus 1 by 2 kBt log of NA by 2 into 2 pi MP star kBt by h square whole power 3 by 2. This value, this equation number Roman 1. So this equation just we got, we are saying it as a 1. But already we know density of holes in intrinsic semiconductor. Density of holes in intrinsic semiconductor P is equal to, it is already intrinsic semiconductor holes derivation, we got it. P is equal to 2 into 2 pi MP star kBt by h square whole power 3 by 2 e power of minus EF plus EV by kBt. It is equation number Roman number 2. It is intrinsic semiconductor holes carrier concentration. Intrinsic semiconductor holes carrier concentration P is equal to 2 into 2 pi MP star kBt by h square whole power 3 by 2 e power of minus EF plus EV by kBt. It is Roman number 2. So in this place EF value, in this minus EF place, we have to substitute this EF value. Entire value of EF should be written here. If you write it, you will get simplification. What are you doing? Minus EF place, this EF place, we are writing this EF value total. Here we have to write. Now we are writing this P is equals to 2 into 2 pi MP star kBt by h square whole power 3 by 2. This E I am writing as a exponential for my purpose of easiness. If I write E is a exponential minus EF. Minus EF means EF value is here. EF value is here. This EF value entirely, the EF value entirely, total this value, enter EF value. Here I am writing. So if I write that one, what happens? Here I can write minus of E V plus EA by 2 minus of KBT log of NA by 2 into 2 pi MP star KBT by H square whole power 3 by 2 was EF values over plus EV by total by this KBT like this we are getting. The next step we are doing so like this. P is equals to 2 into 2 pi MP star KBT by H square whole power 3 by 2 exponential. We are doing separately. This KBT we are sending separately. This KBT we are dividing separately. Then what happens? So I can get here minus of EV plus EA by 2 KBT minus into minus plus. So this minus value, what happens? This minus, you take a bracket like this. Now minus into minus, minus into minus, plus, minus into minus, plus 1 by 2 KBT. This KBT I am writing as a 2. The KBT into 2 KBT into KBT, this value I am writing here, log of NA by 2 into 2 pi MP star KBT by H square whole power 3 by 2. This value as it is we have written, bracket close. So plus EV by KBT. Here this KBT gets cancelled. Here this KBT cancels. So then P is equals to the same term as 2 pi MP star KBT by H square as it is, exponential. We are getting minus of EV plus EA by 2 KBT minus of log NA by 2 into 2 pi MP star KBT by h square whole power 3 by 2 plus EV by kBT. Now what we are doing is P is equals to 2 into the same value I am writing here. 2 pi mg star kBT by h square. Here whole power 3 by 2, forgot top to bottom. Here also whole power 3 by 2 exponential. So here we can write EV minus EV by kBT minus EV by 2 kBT. This value is that we are writing here front side. So plus EV by this value 2 kBT, sorry kBT. This value we are writing here, plus into minus EA by 2 kBT minus 1 by 2 log N A by 2 into 2 pi MP star kBT by h square whole power 3 by 2. Next it is total. So this 3 by 2 as this we are drawn here. This 3 kV EV by kBT is taken here. This 1 by 2. This entire time, this entire term as this we are written here. Then P is equals to 2 into 2 pi MP star kBT by h square whole power 3 by 2 exponential into exponential EV by kBT take common. EV by kBT if you take common, it becomes like this: 1 by 2 minus 1 by 2 plus 1 is EV by kBT. EV by kBT take common, then what happens here? Minus 1 by 2 minus 1 by 2, here plus 1 comes, minus EA by 2 kBT minus log of, it goes up, NA power 1 by 2 by 2 power 1 by 2 into 2 pi MP star kBT as it is by h square whole power 3 by 2 whole power 1 by 2. like this we are getting, like this we are getting, means here we applied 1 by 2 log x is equals to log x to the power of 1 by 2. This we have done here. 1 by 2 log x, if you take log x to the power of 1 by 2. 2 power also 1 by 2. 2 pi mp star kbt by h square whole power 3 by 2 whole power 3 by 2 whole power 1 by 2. So this 1 by 2 is coming here. This power I'm also writing 2 power 1 by 2. This is also coming to power of this 1 by 2. Like this we are getting. Then p is equals to 2 into 2 pi mp star kt kbt by h square whole power of 3 by 2 exponential of this value is plus 1 minus 1 by 2, 1 by 2. So EV by this minus 1 by 2 plus 1 value is how much? 2 kbt happens. This entire value is going to become 1 by 2. Its total value is going to become 1 by 2. So 1 by 2 into this one. So EV by 2 kbt minus EA by 2 kbt minus of log NA power 1 by 2, 2 power 1 by 2, 2 pi mp star kbt by h square. 3 by 2 into 1 by 2 is 3 by 4. This entire value bracket close. Now if I write this one, p is equal to 2 into 2 pi mp star, what is that, kbt as it is by h square whole power 3 by 2 exponential we can have EV by 2 kbt, EA by 2 kbt. So we can write EV minus EA by 2 kbt minus log of n A power 1 by 2 by 2 power 1 by 2 as it is 2 pi mp star kbt by h square whole power 3 by 4. Like this we are done. What we are doing is here small modification. This exponential we have to send into the bracket. Then we are getting like this. P is equals to 2 into 2 pi mp star kbt by h square whole power 3 by 2. This I can write exponential EV plus EA by kbt, this value, next minus this value exponential of log of n power of 1 by 2 by 2 power 1 by 2 into 2 pi mp star kbt by h square whole power 3 by 4 is completed like this. Here what you have to do is exponential a plus b, just like this is exponential a, this is exponential a, this is exponential b. So this minus exponential of a plus b, exponential of a into, then we'll get into exponential of b, like this you get it. So this minus becomes into, minus becomes into minus log.